Hello and welcome to Astronomy with Mr. Guerin. In this first video on objects in the sky, we're going to look at some of the most common things we see in the sky. We'll learn what they are and how to identify them. In the second video, we'll look at some popular constellations and asterisms, as well as how to use these to find famous astronomical objects. For each of these objects, you need to be able to write a sentence to describe them, or identify their name from a description. The Sun is a fairly ordinary star, but because it's so close, it appears much brighter than anything else in the sky. It lights up the whole sky bright enough for us to do anything humans do, and is too bright to look at directly. In fact, it can dazzle drivers, and makes smartphones difficult to operate. In daytime, the Sun is high in the sky. It appears as a bright yellow or white disk, and makes the rest of the sky blue. At sunrise and sunset, the Sun is low in the sky. It appears less bright and orange or red, as much of its light is blocked by dust in the atmosphere. When the Sun is just below the horizon, the sky is still fairly bright. This is twilight. There are actually three recognised types of twilight: civil, nautical and astronomical. Astronomical twilight lasts the longest, as the sky needs to be very dark to do good astronomy. And when the Sun is far enough below the horizon, the sky is almost black. This is night time. The Moon is much less bright, but still the second brightest object in the sky. It also appears as a disk, and by coincidence is the same angular size as the Sun, about half a degree. Its light is entirely reflected sunlight, and it appears white with darker grey patches. The Moon's appearance changes over its orbit. Sometimes it is visible in the day, and sometimes at night. And as its phase changes, we might see all of it, some of it, or none of it. A full moon can be bright enough to read by. Stars are much dimmer. The thousands of visible stars can give enough light to make your way through dark country roads, but only when your eyes are fully dark adapted. Stars are enormous balls of gas and plasma producing light by nuclear fusion, but they're so far away that they appear as a single point, with the largest having an angular size of only 1/20th of an arcsecond. Even our best telescopes can only resolve them to a few pixels. Since stars are so small in the sky, they appear to twinkle. This is caused by their light being refracted by the moving masses of air in Earth's atmosphere. See my video on the Earth for more of this. This is the easiest way to be sure something is a star, as other objects almost never twinkle. Stars are spread unevenly across the sky, and sometimes we see two next to each other. These are called double stars. However, they're not really next to each other, as they are at different distances from us, such as Mizar and Alcor in the Big Dipper, which are more than a light year apart. Some stars are actually next to each other, in orbit around each other. These are called binary stars. However, these are too close for the human eye to distinguish, so any double stars you see without a telescope are called an optical double. Stars often exist in small groups called clusters. There are two main types. Open clusters are a few hundred stars. They were formed by the same interstellar dust cloud, and are loosely held together by gravity. These look like a faint fuzzy patch of light, often with a few bright individual stars. Here we see Pleiades, also called the Seven Sisters, because the Greeks could see 7 bright stars. Globular clusters are too distant to be seen with the naked eye. They are spherical groups of thousands of stars, tightly bound together by gravity. They form on the outskirts of galaxies, by processes we don't fully understand yet. A nebula, Latin for cloud, is a large cloud of dust and gas, formed in a few different ways. They are very faint, and if you want to see one with your naked eye, you'll need a clear moonless night with minimal light pollution and good dark adaptation. To the left you can just see the Orion Nebula, the middle of Orion's sword. To the right is the Andromeda Galaxy. If you can't quite make them out, I've also given you telescopic photographs of both. Nebulae and galaxies are not the same thing, but they used to be. The Orion Nebula is about 1 degree across, twice the width of the Moon, although much less bright. The nebula is contracting due to gravity, forming new stars. The Andromeda Nebula, as it used to be called, has a spiral shape. In 1920, the Great Debate saw astronomers arguing whether objects like this were nebulae or other galaxies. At the time, most astronomers thought there was only one galaxy, the Milky Way we live in, and that the universe was only the size of the Milky Way. Indeed, the word galaxy comes from the Latin for milky. The great debate was inconclusive, but in 1923, Edwin Hubble found a Cepheid variable in the Andromeda Nebula, and its analysis proved that it was far outside the Milky Way. The Andromeda Nebula became the Andromeda Galaxy. It's the nearest and largest visible galaxy, 3 degrees wide, 6 times the angular width of the Moon. Nebulae and galaxies are very similar in appearance to the naked eye. If you can make out a spiral shape, you're looking at a galaxy. But if not, it could be either. Our solar system has 8 major planets, including Earth. Only 5 are visible in the sky without telescopes: Mercury, Venus, Mars, Jupiter and Saturn, as well as very rarely Uranus. Planets look very similar to stars, but there are 2 main differences. 1. Planets don't twinkle. Twinkling shifts the light from a star by around 1 arcsecond. Since stars are much smaller than this, twinkling is very noticeable. But planets are usually much larger in angular size, so we don't notice twinkling. 2. Planets move in the sky compared with the stars behind them. Here we can see Mars, Jupiter and Saturn move over just 4 days. They also get brighter and dimmer as they move closer and further away from Earth. An object in almost the same position, but not quite, today and tomorrow, must be a planet. Comets are a rare and special sighting. They spend most of their time in the outer solar system, rarely coming close enough to be seen. Comets are mostly ice and rock. When they visit the inner solar system, the ice is heated by the sun, and some might vaporize. This releases gas, and also cracks open rock to release dust. The solar wind pushes the gas and dust away from the comet, creating 2 tails which reflect sunlight. If the comet is close to the Earth, these can be clearly seen, often in the day as well as the night. The best comet in recent years was Hale-Bopp, which in 1997 covered a quarter of the sky with its tails. There are countless meteoroids in the solar system. These are tiny rocks, only a millimetre or less across. Every day, millions of meteoroids enter the Earth's atmosphere, at speeds ranging from 20 to 70 kilometres per second. Their very high kinetic energy is turned into thermal energy due to atmospheric friction, disintegrating them and, if they're big enough, making them shine bright enough to be seen from the ground. They typically last less than a second and cover 2 to 10 degrees of the sky before completely burning up in the upper atmosphere. Most meteors are the remains of the tails of comets that once crossed Earth's orbit. Comets leave their dust behind them in a particular region of space, and if the Earth travels through that region, we will experience a meteor shower. Under good conditions, an observer on Earth might see a meteor every minute. The comet was travelling in a particular direction, and so the remains of its tails travel in the same direction. So the meteors appear to come from the part of the sky that the comet came from. Due to perspective, meteors appear to radiate out from the comet's origin. We call that the radiant point. We can find the radiant point for a meteor shower by sketching many meteors or using a long exposure camera over an hour or more. Try to identify the radiant point in these 2 images. Hopefully, you picked the locations of the orange dots. Rarely, a large meteoroid enters Earth's atmosphere. These are typically rocks from the asteroid belt, or occasionally the Moon or Mars. Very large rocks can survive their trip through the atmosphere without completely burning up. The part that reaches the surface is called a meteorite. In 2013, a 10,000 kilogram meteor exploded a few kilometers above Chelyabinsk in Russia, releasing 30 times the energy of the atomic bomb used on Hiroshima in 1945. This is called a fireball. In 1992, a 17-year-old American, Michelle Knapp, had just bought a car. She drove it home, went inside, and heard a loud bang. Her car had been destroyed by a meteorite. She paid $300 for the car. She later sold its remains, including the meteorite, for $25,000. The aurorae are beautiful light displays. most easily seen at latitudes 70 to 80 degrees north and south. Charged particles from the solar wind interact with the upper atmosphere, exciting and ionizing molecules, which then release electromagnetic radiation. The light produced is the aurorae, most often green light, though all colours can be produced. They appear as shifting curtains of coloured light, which change over seconds and minutes. The last natural object on the list is a supernova. There are a few types, but the main one is created when a very massive star reaches the end of its life. The star's core collapses, releasing a tremendous amount of energy in a shockwave, which spreads out the star's outer layers. The expelled gas can outshine an entire galaxy until it cools over a few weeks or months. Supernovae are rarely visible to the naked eye, and the last visible one was seen in 1604. A supernova appears as a bright new star, where that star was previously too faint to see. It will be bright at first, possibly even visible during the day, and will fade out over several weeks. You can distinguish a planet from a supernova, because supernovae don't move relative to the surrounding stars. When observing the sky at night, you may also see artificial satellites pass overhead. They typically travel north to south or south to north, and appear as bright white lights, reflecting the sun's light for up to a few minutes. There are 5,000 satellites in orbit today. By far the largest is the International Space Station. At 100 meters across, it can outshine Venus, the brightest planet. Iridium flares can be even brighter, reflecting lots of light with their door-sized antennae, but only for a few seconds as their orientation changes. Iridium satellites are an obsolete technology though, and they're gradually being abandoned and deorbited. And finally, we come to aircraft. At night, aircraft are too low to reflect the sun's light, but they have their own navigation and identification lights, which flash red, green and white. Depending on the weather, they may leave a condensation trail of water behind them, which might be lit by the moon. Aircraft are visible until they disappear behind trees, buildings or clouds, and if they're low enough, you might even hear their engines. Here is a summary, with one sentence for each of these objects to describe how they appear to the naked eye. You should learn each of these descriptions for the GCSE. In part 2 of this video, we'll look at constellations, asterisms, and pointer stars. Thank you for watching. Goodbye, and have an excellent day.